We are very much pleased by your presence, sir. On behalf of VCET and Department of Computer Science and Engineering, we once again welcome you, sir. Let us invite our resource person to move this session forward.
Thank you, ma'am. Thank you for the wonderful introduction of myself. And I wholeheartedly thank the Vellalar in Engineering College Management and the organizers of CSE department for giving me the opportunity to take to our own fraternity. So, with no other further delay, we can start the session. And I hope you have been into the past 3 days, like the you are hearing the buzzwords of blockchain, IoT applications, protocol, and how to combine IoT and blockchain, all these things. Anyhow, and in the previous session also, you might be knowing the applications of blockchain and blockchain industrial applications also. Okay, in my session, actually, I have a topic for Ethereum uh, types, I mean, Ethereum components and types of a blockchain. Okay, what are the various blockchain types, and one platform it need to be explained here. So that is the topic given to me, and I will take you through the slide shortly. Before entering to the slide, a small request to the participants, those who are present here. Because this is a post-lunch session, it might be very tough because we know what will happen after the post session if we hear a lecture or a seminar. So I would like to place a request to the participant, like be an interactive, so that your inputs may give me a boost to carry forward through the slides. And also, I would like to, you can unmute yourself whenever you have a doubt or query. So it feel make a session to be an interactive one, so that everybody can, share their knowledge, and we can enjoy throughout the session. Hope you will have a wonderful session, and your takeaway will be some of the research topic and various application where to implement what kind of blockchain. Okay, so is it audible? Any disturbance, ma'am? Am
No,
I
sir, no,
okay?
sir. It is clear, sir.
Okay, okay. Thank you, thank you.
Thank you.
So before starting our slide, I would like to know the uh, meaning for the words. Like, can someone explain what is trade? You can also post in the chat box, or you can unmute yourself and say. So, what is mean by trade? So, anybody can interact. So I have three words. So like trade, transparent, consensus. Because these things you might be discussed earlier in the sessions also. So can I get any inputs so that it will be much easier for me to explain the concepts? Anybody? So what is trade actually mean? You can also post it in chat if you feel. I mean, if you are inconvenient in unmute and speaking.
Sir,
Yes, ma'am.
it's a type of business like that, sir.
Yeah, trade actually, a trade is not exactly, we can say trade is not actually a business, but whenever in business we will say we will use most commonly the trade. Okay, whenever a business happens, or whenever something a user get and buys, or whenever he sells to somebody, he get things. So that complete part we call it as a trade. In ancient days, if you see, like getting things from a shop, or at the time we don't have proper money to buy all those things. So what kind of the things earlier days they had, Okay, so in earlier days, it's like they will keep some things like it might be a gold coin or it might be some other products they produce. Okay, so they will exchange the goods, whatever they have, they will give to that particular vendor, and they will get in return back from that particular buyer. And so this buyer and selling concepts is particularly meant to trade. Okay, so then slowly the coin terminology existed. So what is that coin? Initially, it was here in our countries, like we will call it as Ana. If someone, most of them may know that. So 1 anna, 5 anna, there's a maximum price we had at that time. And also after that coins, we came to the rupee notes. Okay, so before that coins and all, you may be say there is a hole in coin, so that used as a currency at that time to purchase something or to do the trades. So this is the thing there, and actually the transparency is also there. Okay, so the transparency, I mean, so whatever we buy, we will give a particular amount, and it's not that much population at the time, so it is easy to handle all those transactions. So that is very easy. So the transparency is there. So trade is there, transparency is there, and the new thing terminology word that has been introduced is consensus. So consensus is nothing but it is a decision making method. We can say like that. It is a group decision making method, which is probably incorporated to this particular technology called blockchain. Okay, so slowly we started from that coin, and that coin we moved to the rupees, and we have different countries having different currencies, and each have each name. The same way here, in order to surprise the gold rate and sorry, to suppress the gold rate, our founder, we call him as Satoshi Nakamoto, and he has introduced a peer-to-peer digital currency or electronic transmission system, which is used for the digital currency or cryptocurrency, whatever you can call it. So he introduced that in 2008, and we have a white paper also. So I will show some of the basics through the slides. That how the technology, from where he got those idea, what technology he has combined, and all I will show you. And one more thing is like, so when I run a shop, see, please understand this phase. If you are, you can relate these terms to the blockchain terminology. If you can, that will be well and good. Okay, so I will say a phrase, and you can relate that words in the particular phrase to the blockchain terminologies, whatever you remember for this past 3 days, or else I will explain later. But I'm curious to know from your end, so that it will be very helpful for me. Okay, so the phrase is like, I am running a shop. Okay, in that I have an accountant. Okay, so I call an accountant, and what I am doing, I'm calling that accountant, and I am saying, take a notebook and write the balance sheet. Take a notebook, write the balance sheet, and then okay, get verified from the manager and owners. Okay, get verified from the managers and owners, then you keep that book in the safe. Okay, so take a notebook, write a balance sheet down, then get verified from a manager and as well as the owner, then keep that book inside a safe. Can someone relate these phrases or words to the blockchain terminologies, that what exactly mean each word? Anybody? So, which words relate which terms of blockchain? Any guesses? You can. So probably I will post in chat what are the terms are there. You can also come through that. So these are the keywords I am giving. You can relate to the blockchain terminologies. Um and I expect the answer. I can wait for 2 minutes.
So that is getting verified from the owner can be that decentralized central organization. This notebook might be that is the cash can be the Bitcoin.
Okay,
Some
okay,
flat
good.
currencies,
Okay, ma'am.
and then next one
Any other
getting
thing?
the owner can be that is the address or the wallet address.
Okay, 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 ma'am. So some partial right answers we can have, but now you can check. Can you map this with the? Yes, the mapping can be done.
So notebook is the ledger, and then
Yes,
balance sheet or safe whether it is if that is cryptography. Getting verified from the owner is the consensus.
yes, ma'am. That's correct, ma'am. Great, great. Thank you, thank you. Okay, so that's great. So this is how we generally say what is blockchain technology in 4 words: ledger, cryptography, and consensus transaction. Okay, so this is the 4 words we commonly use in a blockchain, and this is what we face from a day-to-day life, whatever the things we do, and that is how we all come up with already these terminologies are there, but we have collectively combined together now to form a new terminology that is given by Satoshi Nakamoto. Okay, so I will move through the slides one by one so that we will progress through our topic. I will share my screen. Is my screen visible, ma'am?
Yes, sir, it's visible, sir.
Can you able to the slides and please check
Yes, sir.
whether
Yes, sir.
it's
It
moving
is.
now?
Yes, sir, it's moving.
Okay, okay, thank you. Okay,
Okay, sir.
okay. So today the main important concepts we're going to see is like what are the types of blockchain we have, and the platform for a blockchain which has been we can say as a version of a blockchain also, it's 2.0, and that is called as Ethereum and its component. So these are the topics we are going to discuss today. And so first few slides will be as we discussed earlier. The this is what the agenda today, like introduction, basics, and the types, applications, and finally Ethereum and its components. Okay, so the basics that we have already discussed, and you also know what is cryptocurrency, what is Bitcoin, what is a ledger, what is account, what is wallet. So many of them might have been also discussed types. Okay, I mean, except the types, I think you might be heard all those things. Okay, so here the general definition for a blockchain, as we all know that blockchain, this is the definition given for a business network or a corporate perspective, we can say like that. Okay, so it is an immutable shared ledger and which facilitate the process of recording transaction, and it can track the assets also in a business network. So what is an asset? An asset can be a tangible, it can be maybe a house, car, cash, land, whatever things you call. So that is a tangible asset are there, and also intangible asset. So intangible is nothing but intellectual property, patent, copyright, branding, and advertising, this kind of things. Okay, so this is called particularly blockchain. And what is important in blockchain? What is the best of blockchain, or what are the advantage of blockchain? I won't. I am not going to discuss any of these things here, because you might all know it is well known for its security, and you can know you can adapt to any kind of technology and how it is working. All those things you might hear in the previous lecture also. Fine. So the next slide we will think about. We will talk about the earlier transaction. So here, the earlier transaction is in the bank. How it will do with the help of an auditor. So if you want to file anything, if you want to get any transaction done, so you will have a help of an auditor. And whenever a digital era occurred in 2000, so that digital era made this bank's transaction all it into a digital encrypted form. Digital signatures are evolved there. Okay, at that time, the auditing has been done by this third party, and they have the data to be encrypted from the end user, those who are sending the files to them. Okay. This is what I am speaking all about, the digital flow, how a bank has been done. Okay, so in a bank there will be a ledger statements available, and all the ledgers will be filled by the auditor's statements. So how it will be filled? Everything will be digitally signed or encrypted. So this is how the digital flow has been initiated. And next slides, you can already, you might be heard this one. What is a Bitcoin? And this is a white paper. So which is given by Satoshi Nakamoto in 2008. Okay, he only coined the electronic cash system, which is a peer-to-peer payment and directly sent from one party to another third party, which is avoiding the that third party. Okay. So here he combined the two main technologies like proof of work and elliptic curve technology to get this blockchain. So these slides are mostly you can see then and there. Most of them will be repeatedly how a blockchain is working when it sends to money to be. It is represented as a transaction. That particular transaction is stored in a block, and that block is put it into over the decentralized network. okay, or centralized network it may be. Before, the Ethereum evolves, it is completely, we cannot say it is a decentralized network, but it is a distributed network that we can say. So that distributed network, we will put the block into that, and after some consensus, I mean the group has approved that particular block, that block will be added to the existing blockchain. That's how the transaction will be complete in this blockchain. And here, the money or coin, we can say that as a cryptocurrency. So here the cryptocurrency transaction is explained here, how a transaction is done. So these slides you might be you can also see in earlier also, and some other maybe because it's all available in the white paper as well as on the book. Right. So, what are the futures of cryptocurrency? The cryptocurrency, it doesn't have any intrinsic value. It is another remedy for or commodity, we can say, for gold. Okay, it doesn't have any physical form. Only digital form alone we can see or view the cryptocurrency. Then it doesn't given by or governed by any banks. So it is completely in the decentralized network. So this is what all about the cryptocurrencies. So here also the same process, how the blockchain gets work. When A requests a transaction to B, the request has been placed as into the network, and the network validate, and after validation verification is done, then it is added to the existing block. And you all know the first block, whatever in the blockchain, we call as a genesis block. And that is very very important in creating or using a blockchain terminology. So that is also we will discuss later while we see Ethereum. Okay, so here after all these things, whenever the block get added to a existing chain network, then the transaction will be finally complete. So this is a transaction view, and if you see the process flow, we can uh, yeah, this is what the four words actually I was telling you with the phrase, with an accountant open a book, notebook, he writes the balance sheet, and he gets verification from a owner or manager, then he keep it in a safe. Okay, so this is what the thing. The notebook is nothing but a distributed shared ledger, and the safe is nothing but the cryptography, which we call as a lock key. And getting verification from one or more party is nothing but a consensus. And smart contract is a very very important term. Uh, Here in Ethereum only we will be using this smart contract. In normal blockchain version 1.0, we will not use any smart contract. So smart contract is nothing but programmable, or we can say a smart program that can be embedded for doing the transaction. Okay, so that I will speak about the smart contract in the later slides. You can have a view here, like what these are of key concept of the blockchain. So you should not forget these four things in this four quadrants of a blockchain, we can see. Fine. So these are the trust factor of blockchain. Like you might be heard, it is secure, private, indelible, and it is a distributed one, sustainable one. So we speak about transparency. So it is a transparent and auditable, because if I am opening to the public, then we can share this. Anyone can view what is there, or how many blocks are there, that kind of thing they can view, but the data cannot be viewed. So that I will also say how it can be prevented, or how it can be secured. And consensus based, okay, so it is orchestrated, scalable, and flexible. So this is what the trust factor we have kept on the blockchain, right? So the next thing is versions of a blockchain. Yes, here we have totally four versions considering the current version. And you all know that Bitcoin Ripple, Dash are the types of, like it is also a form of cryptocurrency. So in version 1, what we can do? So it is money. This money can be stored and transferred for some particular values. So that what happened in blockchain version 1, and in 2.0 has introduced that programmable version. So that programmable version is nothing but smart contract. Smart contract is a piece of code or piece of program that runs uh, to automate the transaction or to enhance the decentralization in the blockchain technology. So here comes the framework called Ethereum. So Ethereum is coined, basically we can say it is a decentralized application which is specifically meant for a blockchain. So this is in blockchain 2.2, and here also some flaws are there, and the version 3.0 has been overcome. And in 3.0 they particularly focused on enterprise blockchain, so specifically for most of the business use cases and business purposes. So you might be seeing many applications or most of the industries and many applications are e-voting, we can say, shipping industry, logistics, this kind of industries we can say. So all these things, for that particular enterprises, they have meant, especially without the smart contract we can say, and non-financial users we can say. So that is called blockchain 3.0, and here the platform used is Hyperledger. So Hyperledger is one of Hyperledger Fabric is one of other platform of blockchain, or we can say the third version of blockchain. Here in this Hyperledger, we won't use any that cryptocurrency terms here. Okay, it is also a programmable one, but we won't use any currencies, cryptocurrencies here. Okay, so RC Corda and Ethereum Quorum also supports the blockchain 3.0 version. And next gen only, it is highly scalable with high concurrency. That is, most of the hybrid chains are coming in this versions. For example, Dragon chain, Arch chain. So Dragon chain, Arch chain, these words you might be heard, and this we are getting in this current generation. Okay, it's not termed as 4.0, but they have given the next generation version, so which is highly scalable with high concurrency rate, and the transaction cost is less, and it belongs to the hybrid blockchain. So I will say what is hybrid and what is public, what is and all that is what we are going to see next. Okay. So blockchain types. So here the blockchain types, we have public, private, permission, consortium, hybrid. So usually the three things, public, private, hybrid, but the two extra types are like permission and consortium is also there in our that blockchain types. Okay. So here you all know this three words: public, private, hybrid. So we are studying from the object oriented concepts itself, from C++ or Java, whatever programming language we study. Whenever we say that object oriented concept, then we have this public, private, and hybrid. So mostly we know what is public means. So public means we know it is open to all, so that we are well known to that. So public means it is open to all, well known, the code is there, so it is like a open source, we can download and we can do all the kind of things. Yes, that is correct, whatever you are thinking, that is correct. Fine. Any other things apart from this, any key features for public blockchain? Any other things are there? So what will be a public blockchain holds? What are the features will public blockchain will hold? Is it open to all, and it is, is it a high secure or low secure? If we say the code is open and all this thing, whether the how about the security of a public blockchain?
So it's enhanced security, sir.
Yes, ma'am. Good. Thank you. So public blockchain, we say it is open, and also, so someone also posted in chat, maybe low secure. That's actually the thing. We will think like that, but it is not actually low secure. Okay, so fine. Public blockchain is also, it is a secure one. Okay, fine. So let us move into that. Okay, so this is how the public blockchain is meant. The code is completely open and transparent. So in the phase of transparency, we see how the blockchain that anyone can join and participate, which is similar to a Bitcoin, and as well as the smart contract. Also, some of the smart contracts are open source, and which are developed in this aspect. No, it should be transparent. It should be made as a public. And here we should have no small drawbacks, as we thought like it has been weak security or no transaction. But here the security is not a weak, or the transactions are weak. The computing power, and some might may stole the data. We should not, we should be careful for our data, because anyone can modify the data. Is it possible, these words whatever I am speaking now, anyone can modify the data in the public blockchain? Is it is possible, or any hacker can interrupt and he can modify? uh, is it possible?
Sir, anyone in the network can view that information, sir.
Anyone can view the information. It's actually view the information means they can view the block type of information, not exactly what present in the block or what transaction is there in the block. They cannot view, but unfortunately they cannot modify the block information. So that is
Yes.
what here in public blockchain.
Yes.
But whoever, maybe they can participate in the public blockchain, and they can be they can add their blocks to their particular existing chain. That can be done. And most public blockchains, you may have heard that Bitcoin, that is a most public blockchain network, and Litecoin is also there. Okay, and you see the final point in the slide, that public blockchain are mostly secure if the user strictly follow the security rules and methods. So that is a thing I need to address here. The user, whoever join that particular chain or network, they need to follow or adhere to that particular chain network rules. So such that the chain will be developed, in a enhancing manner, and as well as you can also ensure the security, and you can keep safe of your data, and it is absolutely free to use. So this is the public blockchain. And here comes the private blockchain. So private is meant especially for our enterprises or organization. In our own college, we can make a private blockchain network. So here what happens, there will be a rule set of rules that is like, those who are in an organization alone, they can join this particular network. So it is also decentralized one, peer-to-peer network only. But that particular organization controls all those things. So they have a certain rules, and they have a certain protocols. They permit this to do, this transaction can happen. So everything can be customized here. So only that particular organization can be customized, and they will have a consensus. They will have their own consensus mechanism. Okay, so they will form a committee or group. They will give the authority to for that particular group to execute the consensus protocol. So this will be there. And so depending on the the use case, it can be the trust and confidence between the participant can be significantly improved. So that is what here in the private blockchain. So every corporate it can run behind its own on its premises, and its within its firewall. So this particular blockchain networks will not be shown to the public because it will be hidden within its firewall. So it will not be identified whenever a public user is trying to check that particular network. So this is what the private blockchain. Here the ownership is maintained, and it is a digital identity, and mainly it is useful for the supply chain management in various organizations. So Hyperledger is specifically mentally used here for this private blockchain network. Okay. So here comes next the permissioned blockchain, which is similar to the private blockchain, but it's like invitation based. So whoever I am inviting, they can alone participate here. It is an invitation based, and or we can say like they are these participants are given permission to attend. It's similar to in our college on duty sanctioning. So these are the guys, those who are permitted to attend this particular event. The same thing, giving permission to the particular people to enter into that particular blockchain network and make use of that network. So this is what permissioned blockchain network. And several corporate and businesses also they are adopting this permission because their buyer and their seller alone they can connect together. So that is what the major use of this permission blockchain network. And if you see next, we need to have a difference, major differences about this permission and permissionless. So in public we cannot do or we cannot restrict the user because it is a public blockchain network, so it is completely permissionless. But in private we can make all those things whatever all we want to do, that we call as a permission network. So that difference we will see here, like what is permissionless and what is permission. See this permissionless, as I said, it is a public blockchain and anyone can process the block. Okay, so here the example, as you know, if we are speaking about the public blockchain, then automatically this Bitcoin Dash Ripple will come because all these things only public blockchain. And Ethereum is a framework which is also used to develop the public blockchain. So that is the point I have to add here. And we have the permission federated. We can also say that as a federated one. And here all those things it based on the trust factor. Okay, so who are all the processor, it is already known. How many blocks are there, it is also already known because it is within an organization. And here less processing are required because the group is very small, the audience here is very small. But whereas in public the processing time is very very more. It can take a minute, but here within a second the transaction may happen. So these are the things you might be into keep into the mind, like what is permissionless and what is permission. Okay, so each one it has its own advantage and its disadvantages that we will speak up in the forthcoming slides. And we have two more things like consortium and hybrid. So what is consortium? What is consortium blockchain? Can anyone say what is consortium? What does it exactly mean? Consortium. So here in apartment and all, they will say as gated community, community, gated community. We can say a small forum. Uh, can you relate anything to this to consortium? Pardon?
So it might be multiple organizations using the same chain.
Yeah, share. Yeah. The
Chat.
share
Yes.
has been actually, it has been distributed to a specific people. Here, it is not open to the public, but it is shared, but it is restricted. The share is restricted. That's all. So that is consortium. If I say I am forming a community, or I am so in simple words, I can say I am forming a WhatsApp group. So you maybe form a STTP WhatsApp group for this. So only you will share the content to that particular group. Or if you are hosting, if you have a partner institution, what you will do, you can also host it. You can give access to your partner institution. So only that two institution can participate here. The same way, whatever the consortium blockchains will do, it will ask for who are all the consortium members in this particular network. So it will get the consensus or previous responsibilities, who will maintain the particular blockchain network, all these things, what are the rules for each and every organization. So everything they need to submit or as a data, and it is combined, or it is consolidated as a consensus protocol, and that is made as a consortium blockchain. Here it is suited for business people, multiple or group of people doing a same business. Okay, they can in different state, or my own branches I have in different. So, for example, I can say Chennai Silks or Pothys, so wherever what. So it has been spread across over our our state. The same way they can come into this. Okay, so it is typically consortium blockchain, and here the example we have standard thing is R3 and Energy Web Foundation. These are the consortium blockchains that are very popular. So, whatever examples I am giving here are those are mostly used, most recently used, and most popularly used that I have taken and I have done. Fine. Next one, as you all know, what is hybrid? Hybrid is a combination, as you know, all know, public and private combination is hybrid. So both the futures are here. So permissionless and permission, both are combined. So how and which way is made public and which way it is made private. So that it differs upon the network that it forms. So if for example, we take a Dragon chain, it is a hybrid blockchain network in which a selected section of data or records from the blockchain can be allowed to go public. Okay, the rest will be a confidential. Okay, they will be select. Okay, this two from 1 to 10 blocks can go public. So other maybe it can be a restricted one. So a transaction in a private network of a hybrid blockchain is usually verified within the network itself. So coming into the transaction, you can understand better when I speak in Ethereum. So what is transaction, how it happens and all, you can understand there. So it is more flexible, and here what the users can join as a public member, and if they are comfortable with this the permissioned one, they can use this, or they can simply go. So that is the benefit of this hybrid blockchain, and the example is, as I said, like Dragon chain is the example. Okay, so this is what the main major types of blockchain which we have classified, and these are the pros and cons. That is for the various blockchain we have seen. So this is what. So each and every network, blockchain network, or every type, I can say, probably it is what the advantage and disadvantages, if you see. So one is better. One is better for this. One is better for. We cannot come to a conclusion that public is best one, private is best one, or consortium is best one, hybrid is best one. We cannot say like that. Okay, so based on how it is chosen, you can see. For example, I can say if I am running an organization. Okay, I have multiple branches. I might be choosing the consortium hybrid network. Okay, for example, I have a shipping industry. Okay, I can use my private, or I have a if a government is probably trying to implement something for our state. Okay, so I would like to say word here, like TNEGA is a government initiative of Tamil Nadu's e-governance agency. They are particularly focusing about blockchain. So our state is already started implementing the blockchain in various sectors like agriculture, in land registration, all these things. Okay, so special group, special a team is formed for that, which is named as TNEGA, and most of the members are, the senior members are there. Our college professors is also a part of board members there. It and the industry people are there. They are still hiring more people for TNUGA in order to uh, develop the particular application and implement in the state. So we have upcoming project of our state government also there, and if they are trying to give you the application and use, probably maybe the e-voting is there, we can say. So it is led to as a public blockchain. So based on the use case only, we can able to select that particular which kind of or which type of blockchain network we might use. So it is chosen based on the use case. So this you can remember here. You can take away from this slide. And so here this is a comparison. You can have a comparative view. I think I don't want to explain much in here. Okay, so and one thing, the disadvantages in private, I will explain that centralization and IAM. So IAM is particularly identity and management. Okay, so that identity management is revealed in private. They can easily come to know whose block is that and what information they are. So that is why we say that private network has less security and comparatively low trust. And the TPS is nothing but that transaction processing speed. Okay, so that is transaction processing speed, how much rate, in what rate a transaction is done. Okay, so that is what given in that private address. So others might be, you can probably have a look and you can read itself, so that is understandable. Okay. So this is what all about the type of blockchain. So far, if you have any doubt or any query, you can ask, or else we can move to our framework, Ethereum. Can we pause for 2 minutes and take any questions, or shall we move?
Participants, if you have any doubt, please unmute yourself and ask the question to our resource person. Or otherwise, post your queries in the chat box. So now queries, sir.
Okay, okay. Shall we continue?
Yes, sir. Yes, sir.
Oh, thank you. Right. So next part is a concept called, or a framework, we can say it as a blockchain version 2.0. It is nothing but as an Ethereum. So mostly you might be hearing this thing, and Ethereum. What is Ethereum? What is that Ethereum? So many of them are saying Ethereum blockchain. I am still getting confusion, like what is blockchain and what is Ethereum blockchain. Or you might be having what is smart contract. What is actually Ethereum mean? Okay, so for all your questions, here is the answers. So in this way, you can remember Ethereum is a decentralized platform that runs the smart contracts. Okay, so you can develop many applications based, I mean, many decentralized application actually that is programmed, okay, without any possibility of a downtime, censorship, or third party interference. Okay, with these things, these are the major prerequisites for this, the major thing to evolve the Ethereum. So there will be the no downtime, there will be no censorship, so the transparency will be there, and no third party interference will be there. And this is how the Ethereum we define here. The Ethereum is a word that is kind, you might be wonder, who has developed this terminology Ethereum, or who has introduced this, founded the Ethereum. Anybody said previously, like who has introduced Ethereum? Who was a founder of Ethereum? Okay, so founder of Bitcoin, founder of blockchain, you will say Satoshi Nakamoto. But here is one more person who has founded the Ethereum. It is a powerful and trustful blockchain environment which is developed using the smart contract. Probably DApps we call. What is DApps? It is nothing but decentralized application. So all the decentralized application are developed based on top of this Ethereum platform. Okay, so here is a person named Vitalik Buterin. Okay, he is, and this is how he what he developed, or he introduced the concept of Ethereum. And when he was a 19-year-old, he was a Russian Canadian program. You can Google and see his name, Vitalik Buterin. He has given his concept of Ethereum. So he made that, he extended, or I can say, he added to Satoshi Nakamoto's concept, and he just come with his idea called Ethereum. That was a great success to him, and most of the companies had also implemented it. This is what has, his success in 19 years. Fine. So this is how the timeline when it has been officially released. You see, the idea he has put it in 13. He has also written a white paper which is available in a GitHub. I have provided that reference in my reference slide. I will show you also that also. Okay. So probably you can see this timeline, like it has started from 13. Okay, 13 to 14. 14, it is went for a crowdfunding, and in September 14 they have formed the Ethereum Foundation. Then June 2015 they have initial release. Then they overcome with certain, know that smart contract procedures, automation, all those things they have overcome in that first release. Then finally we officially released in March 2016. So this Ethereum platform they have released in March 2016. Before going to see what are the tools, or what are the various consoles, what are the things present in Ethereum, we need to know what are the key characteristics of Ethereum, and what are the futures of Ethereum. So why we go for Ethereum than the Bitcoin? That we might we should know that first. Okay. So these are the features, key features I can say why we are going for Ethereum blockchain network. So security consists of, so no doubt in that it is mostly secure. And the next point is very, very important. The transaction speed is very high, that is faster. So the network is faster. You can create a block in seconds, and the transactions are approved in seconds. So that is the second, I can say that is one of the important feature I can say, which is faster, and it is corporate friendly. So you know what is the meaning of corporate friendly? What is corporate friendly? Most of the corporate is developing their decentralized application based on this Ethereum, and community support. So we have lot and lot of community support. If you have any doubt in Ethereum, or if you are trying to develop an application over the Ethereum, you are facing any challenge in how to communicate or how to approve or how to mine all those things, we have a huge community support there. Whatever your query, it will be addressed there, sir. I have a reference slide for that. So how the community support is also done, we will see in our forthcoming slides. Okay, then asset insurance. Okay, asset insurance means whatever you are putting as an asset here. For example, in trading and all, uh, they will be having the demat account. All right. So particularly, it is used for online trading. Here we use the same where we call as Bitcoin earlier digital cryptocurrency. Here we call Ether. So Ether is a cryptocurrency used in Ethereum. This is a specific asset we will see. So however you are maintaining the Ether value, that can be that Ether value is your asset in Ethereum. And it is an uncensored one. Uncensored, you might know, it is very transparent, and you can see what is the transaction done latest, who have done the latest transaction. That also I will have a demo. You can see it on a demo link if you permit me. Okay, so that we will see later. But this is a key features we can say. These are the features of Ethereum. So it is secure, faster, corporate friendly, and your asset is insured, and it is a transparent one. Fine. So this is what the architecture will likely to introduce about the Ethereum. It is a single node component in which each node of Ethereum will have its own EVM. EVM is nothing but Ethereum virtual machine. So normally we know JVM, Java Virtual Machine. So what Java Virtual Machine will do? It compile a Java code, and it will compile and it will convert it to the bytecode. That we will know. The same way Ethereal Virtual Machine also work. So whatever transaction represented in a block, it will compile and it will generate a bytecode. So that is what Ethereum virtual machine we call, and EVM. And that this EVM we will also discuss in the future slides. This is architecture you need to remember. So blocks will be represented there, and I hope you all know what are the contents present in the inside a block. So probably block address will be there, and the timestamp will be there, hash will be there, that is your Merkle tree where it is stored. Okay, so previous hash will be there. Then what is the nonce, what is difficulty, that gas used, mined and all, I will explain one by one. So most of the terminologies are there. So in blockchain you will not hear this much of terminologies, but in Ethereum you need to know this kind of terminologies. What is nonce, what is gas limit, how gas value, gas cost is calculated, what is ether. Okay, so I will explain the terminology slowly. Okay, what is node, what is client. Okay, so transaction pools, what is miner, what is the job of miner, what he will do. So this many terminologies we have in this Ethereum. First, if you see, it will be slightly hesitation or difficult to understand only. But if we see part by part, it will be easy, and we can also remember if we understand the transaction, how it happens, or how a Ethereum framework works. If you know this, it will be easy, and it will be coming into a picture what comes here and what comes here. Okay, so transactions are collectively will be there in a mining pool, and it will be done by the miner. Miner is a person or a software, you can say. They can do this transaction automated. All those things I will explain in the first slide. So probably client will be there, transaction pool will be there, miner. So these four things compensate a single node, and in which block, what is will be in block, and this miner will be connected to the peer-to-peer other network, and it has a API interface which has been developed using Web3.js and in Ethereum, or we have so many SDKs. That also I will say what is client, what are the clients available, what are the various version of SDK available, what are the ID, sorry, we will say Ethereum development environment. There we will call as Java ID, right? So for example, NetBeans and Eclipse, that we will say as Java IDE, right? And the similar way we have Ethereum IDE also, Ethereum development environment, which combines all these things together in a single thing. So I will show you also that. Okay, fine. So this is what the architecture is all about, and this is the Ethereum ecosystem. If you see, there are some terms like get, parity, ganache, okay, and truffle, remix, okay, wallet, uh, J Ethereum, NJ Ethereum, CPP, MetaMask. Okay, what is this? All these things, if you see this, you cannot understand. Probably for the first time, if you're seeing this, you might not be understand what is going on, what is happening. Okay, let us take each and everything as a separate one, and I will make you to understand how this ecosystem is formed. So this is the ecosystem. Why I need to show you before is you need to know how it has the Ethereum network is all about, and Ethereum ecosystem is there. Okay, so before or how to form this ecosystem, we need to know the terminologies. What are the things used in the Ethereum? And this is a components, I can say. Okay, so these components are very easy nowadays. There are many user interfaces are there to obtain this Ethereum components. That also I will show you as a demo. Okay, I will show you, just I will show a demo there how Ethereum components are obtained. And see, probably you need to remember the user key, contract address. Okay, what is the contract address? What is the type of contract? And what is the gas value? Okay, what is the gas limit? So these are the main components of Ethereum in UI, this user interface. So if I enter the server URL, from where I need to get Ether, or where I need to do the transaction, from address to address. So all these things are will be stored in a transaction. That transaction we have a separate slide. I will explain there, but you have a note of these components, as well as yeah, this is what I am trying to say. These are the terminologies of Ethereum. These words you need to keep in mind, or you can easily uh, you can see for your reference also. That is, with the help of these terminologies only, the network of Ethereum is working. Okay, so basically, what is node or what is a client. So node or client is nothing but it can be a device or it can be a program which will be communicating with the other Ethereum network. Okay, so it can act as a software. Okay, for example, I have a parity Go Ethereum, so that and all it act as a client. So I have a separate slide for client. I will show you there what is Ethereum client. We have so much of clients involved here. Okay, and what is a block? Block is nothing but it can have a single transaction, zero transaction, or more number of transaction. It is a package of data we collectively call that is a block. So that is a node, this is a block. Then we have miner. Who is a miner? Miner will approve the transaction and add your block to the blockchain. Okay, they are also the nodes in the Ethereum network who always approve, find a new block, and they find or confirm the transaction, and they commit to the existing block. They add simply, their job is what they need to get a new search for a new block. They have to verify the new block and they have to append it to the existing chain. This is what the miner will do. And proof of work, most of them has been explained. What is proof of work? Is it is an activity. Okay, proof of work means whether it is a possibility to approve or not. Okay, there will be a mathematical value to calculate, this proof of work. And for this only we have a word called nonce in Ethereum. Okay, it is exactly we have a in Bitcoin we have a SHA algorithm for the security. Here in Ethereum, we will have ET hash. ET hash we say. So ET hash is an algorithm that we use here for a security purpose, and we have a formula to calculate the nonce, right? The next one is EVM. So EVM, I already said what is virtual machine, which gives you a byte code. Okay, that EVM, it's Ethereum virtual machine. And what is smart contract? So smart contract, I also explained earlier. Smart contract is nothing but as a piece of code, or I can say it is a programmable or executable function written on or set of data. So these function, used for make a Ethereum transaction based on the input parameter. It can interact from one node to the other node based on the input or whatever the program we are functioning. So whatever the code that has been written on the smart contract, according to that, transaction will happen. Okay, so that you can come to know whenever I speak further about the smart contract. We have separate slide for that smart contract. Ether is nothing but I already said it is a currency used in Ethereum network, whereas Bitcoin is a currency used there. Cryptocurrencies, it is Ether is a currency used here. If I am doing a transaction, I need to spend the Ether. Okay, that is what what all about Ether. Okay, so whenever the EVM transaction is done, I need to pay Ether from my account. Okay, so account is there, wallet is there. Account means simply we are having a bank account, right? So we are making a transaction use of that particular account. So within a bank, so if you are making NEFT transaction or IMPS, so what the transaction methods are there, right? The same way we have the accounts like joint account, fixed current account, savings account, and all. Here also we have the account types we have. So each user will have an account, and collection of account or collectively the accounts are said to be as a wallet. Okay, that we will see in the film. And here the important thing is gas. So gas is nothing but it is the pricing value. So whenever I am spending ether, it has been said to us, or we can call the gas as a crypto fuel. Whenever a code gets smart contract is getting executed in EVM, the gas is paid as a execution fee. Okay, so it's similar to like if I am the automatic vending machine is there, right? If I need to dispenser, I get any water or some soft drinks from the dispenser, I need to pay or put some token or account on that particular. The same way, if I need to do the transaction here, I need this gas value. So gas limit is nothing but the maximum amount of I am trying to pay. So for this transaction, I can pay only 100 rupees. So that is the gas limit, you can say. This, for example, not exactly. For example, I am saying. Then mining pool is there. Mining pool is nothing but a group of miners will work together to the mine blocks for the Ethereum network. That is the mining pool. And mainnet is the main Ethereum blockchain network that we term as a mainnet. We have several networks also, Covan net, Reposo network, like that of Ethereum networks are also there. But mainnet is the main Ethereum network. In local host also, we can run this Ethereum. So this is the terminologies that we have in Ethereum. And here what the tools of Ethereum you have, and in which languages or which tools that uses particularly. So these tools are very important. So if you are going to implement any application in blockchain, or you are starting any research in blockchain, it might be very important for you. Okay, so we have a get console. It is written in Go language. Go is supported by Google language, and Google Go language. So the tool name is get, and we have Ganache CLI. So Ganache is an emulator based of Ethereum tool. Here also we can write an application smart contracts and do a transaction. And MetaMask you might hear earlier. So it is a browser based wallet. You can hold up many account. You can collectively use your accounts here. You can do the transaction here using a MetaMask. So it is a browser-based wallet. And we have a Swarm. Swarm is one of Ethereum tool, which split files and store in the database accordingly. So Swarm is like it act as a split file and store manner. And we have Mist Wallet. Mist Wallet is officially recognized as an Ethereum wallet. It is also can do the transaction. It can also have all the files. It act as a tool to do the transaction. It execute. You can also develop and deploy test the application using the Mist Wallet. And IPFS is the tool here, interplanetary file system. Here also, this is one of the mostly used Ethereum tools, I can say. Most of the corporate companies are used for this distributed hash table mechanism. It is working on this tool, particularly IPFS, and it has been implemented as a Ethereum blockchain. And finally, we have Whisper, and it has been identity-based communication protocol. So in that particular mechanism, this tool works. So these are the list of tools and list of the recent tools, or you can say mostly utilized Ethereum tools for developing an application. Right. Then we have Ethereum, followed by the tool. We have a client. We have a SDK, software development kit, and then that environment. Okay, EDE, Ethereum development environment. Let us see the clients for Ethereum. So client, I said who is client, right? We have explained in the terminologies. So we have a client application or client interface, and we have a language based client interface, because most of them will choose Java, JavaScript. They will be comfortable with that. Most of them will be open source language. They will choose Ruby, Python, those kind of languages. Anyway, based on the languages chosen, they might be using this client interface to interact and develop the application. See, for example, Go Ethereum, as we have a tool here, Get console can use this Go Ethereum client as an interface. Same way, Parity also can use Get console. So, likewise, the interface can be interoperability. It can capable of interacting with both, JavaScript, Java language, or also Python language. So, these are the tools we have. And this is a SDK, and the most used SDK are Web3.js and ETH.js. ETH.js, the first and last are mostly used. You can see. So it is developed on Go language, and here it is developed on Java. So this framework, or you can say as an SDK, software development kit, in which the Ethereum applications blockchain network are developed. So this is the EDE, Ethereum development environment. Here you can see these three things. Some might be tomorrow also you have a session of Solidity, like how you will be implementing Solidity program. So mostly they will be using Remix IDE. We have Truffle and Embark. So all these three IDE, what it will do, it uses a smart contract, and each one has its own advantages to develop the Ethereum application. So these are the tools. So Remix IDE is mostly used, and Solidity is the program used there. I mean, it is used as already it is a language used to develop the smart contracts. So the extension you might see .sol. Okay, so if you just Google Remix IDE, then it will be taking you to there, and you can write a smart contracts there, and you can link it to a account that can be explained probably in tomorrow's session uh, by some other people. Okay. So these are the the major difference between Bitcoin and Ether. So I want participant to have a look because these are the main difference of Bitcoin versus Ether currencies. So what actually the difference is, what it use, and how what are the key differences you can also come to know. Excuse me. Okay, so the differences you can see like so the it uses SHA as we know, SHA secure hash algorithm, and I already said it is ET hash. Ether is using. So here the application will be goods and services mainly for Bitcoin, just to transfer the the cash values. Here and the decentralized applications are made where the value, if you see the currency value is currently $3500 for Bitcoin. Here the Ether value is $100, and Bitcoin is used to create, or they their motive is to compete with the gold and flat currencies. But here Ether use token for smart contract. The transaction speed also I have described there. Public blockchain or Bitcoin, whatever it uses, the speed will be in minutes. But here as in Ethereum, it is in a second. So faster, it is a characteristics of Ethereum. And here the proof of work, and here it is a proof of stake. So what is proof of stake, that we will see in the forthcoming slides. So this is how the Ethereum works. I have given you in steps. Like the first block is a Genesis block, you all know, and in this Genesis block we have a Ethereum client or nodes, as we already see the client. What is the client used to interact with the Ethereum blockchain? Okay, so using the client, we can create a transaction, and that particular transaction is broadcast to the network. Okay, and that client will do the broadcast process and all to its peer, and peer will note to the miners. Okay, the peer will be mapped to the miners, and that miner will look into the mining pool. Like the transaction has a greater gas value, or the proof of work is that nonce value is there. Okay, then the miner, once it is validated, then it is added to the then that particular transaction is converted as block, and that block is added to the blockchain. This is how the Ethereum works. We have a process flow at a last. I can say like how to develop the Ethereum. It is a development of a process flow that I will explain as a last part. But before going to that development process, we know to we might to know like the important facts or concepts. This is a cryptography, what is account transaction, and what is smart contracts. uh, Earlier we saw those terminologies, but in fact we need to know these things. So what are the algorithms probably used in cryptography? What are the accounts we have? What do you mean by account? What do you mean by wallet? What is a transaction? How it will be? Okay, then probably smart contract. As we said, how to develop a smart contract, and I will show example for all these things. Right? You can visualize all these things here. It will be like this only if you develop any kind of Ethereum application, right? Okay. So cryptography, we have SHA, ET hash, symmetric cryptography, asymmetric cryptography, and digital signatures. So these are the common techniques or common cryptographic algorithms we are using in this blockchain technology. Okay, so you know what is account? We all owning our bank account. It's similar to this. Uh, if we have a 10-digit or 12-digit account number, here the byte address we will say 20 byte address we have as a account address, and we have two type of account. One is EOA, that is external owned account, and other one is contract account. Contract account is nothing but the smart contract account. Okay, whenever we write a smart contract and we deploy the code, that account will hold the code. Here, the account will not hold the code. That difference I will let you know in short while. Mm, then the account will have the public and private key pair, and this account is very essential to interact with the blockchain. If you have more than one account, then it is said to be valid. So that we know. Okay. So what does the account field contain? The account field contain nonce, ether balance, contract code, and storage. Okay, so these are the four parts or four fields we can say that might be containing in the Ethereum account address. So that we will see one by one. Okay, so this is the external account. So external account has an associated nonce, that is a nonce, as I said, it is a mathematical calculation that the amount of transactions sent from the account and their balance. Okay, code hash will be there. Code hash is nothing but ETH hash also used, or SHA is also used. Sometimes the hash value, it is computed for your particular transaction or data using the smart contract. These two things are associated with the EOA. Whereas the contract account has one more thing, has associated balance and nonce. It can store and execute the code. uh, Here in externally owned account you cannot store the code, whereas in contract account you can store the code. So this is what the two things and the four fields defined in the bottom of the image. You could see nonce, balance, code hash, and storage rule. So these things will be present in the account. So I can show you there later. This is what the private key consists of. 66 characters appended with 0x, and the address 20-bit address also it will be there, which probably mapped with the Ethereum private keys. So this, for example, like this only the addresses are will be there, and real time also I will show you the address which looks similarly to this. Okay. Yeah, this is what the MetaMask. Uh, if you see here, the account address C0x, so which is see similar here. It start with 0x the same way. So it is connected with the Ethereum mainnet. This is what I am speaking in the terminology I use here, right? Mainnet. I will show you the MetaMask demo also if time permits. I can show you the demo. You can also see that how it works and all. See, this is the address, and currently I am having 0 ether here, so it shows 0. Okay, it also has dollar price also. If you have 1 ether, it has been currency value for if 1 ether, how many dollars it will be showing here. And I can buy, send, how much asset have. I can add more number of account. I can add a token here to send my ether to, or I can do the transaction. I can say probably if I need to send my ether to another account, it is considered as a transaction, and that transaction, it will be reflected in the Ethereum mainnet, and which can be monitored in the Etherscan console. So that I will show you during the demo. But remember the MetaMask. Here, this is what I am sending. This is a wallet. MetaMask is a wallet. I can say I can add more number of accounts here. Okay. So this is a externally owned account example. And what is transaction? So transaction is nothing but whenever I need to place a request or I need to send something from A to B, it is called as a transaction. So a state of blockchain is modified. Okay, so what does it mean? I can run a contract. Okay, so it is normally in a global state. So whenever I am running a smart contract to send a value from one account to the other account, so then my state will be changed. So this is what the transaction probably depend, and from where I am sending, to whom I am sending, all those things will be listed here. Okay, you can check here. Okay, so this is the example of a transaction. See the status is like I said, no, the transaction mined and execution successful. If it is in not transfer or failure transaction, we will get a message as failure, transaction not successful, so something like that. But here it is a successful transaction. So see, the transaction has value from address to address. What is the gas limit? I mean the total gas cost involved. Okay, transaction cost, execution cost, hash value for that input address. Okay, so this is what the exact log of a transaction will be, and WEI is nothing but it is a unit of gas. Okay, um, so we were speaking about gas. Actually, gas is used in every transaction. Okay, if I need to do the transaction, I will use a gas. It has a halting problem. The Ethereum network is solving this halting problem. Halting problem is nothing but it run infinite loop. Okay, so it runs an infinite loop. So to avoid an infinite loop, we charge a fee to proceed with the next step and to stop the infinite loop. That is what the halting problem gas. So what is gas price? So gas price, if you want to know, you can refer that link ethgasstation.info. You can check the gas price always here. And as I said, WEI is a unit of a gas. Okay, we have a gas limit. Limit is maximum amount of a gas that the user is willing to spend, and it is help us to regulate the load on a network. This is the gas limit. So gas cost is calculated by multiplying or by getting the product of those above two things. Gas limit into gas price, we will be getting the gas cost. Okay, so this is the total cost will be logged in each and every transaction. So maximum amount of gas can be the block can be used. Okay, so that is what that gas cost. So proof of stake. So we are slowly moving from proof of work to proof of stake. Okay, so this proof of stake, this approach does not require any large expenditure and all. That is what we say. And miners are also called as validator in the proof of stake consensus. Okay, it is a consensus derived for the Ethereum network, that it is a proof of stake. Okay, so here I am going to speak about the smart contracts. Okay, smart contracts, as we all know, it is an executable piece of code or some functions be written there to do or automatically trigger the transactions. So this is what all about smart contract. It consists of ether balance. It consists of executable code. Okay, so it solves the operations of arbitrary complexity. Okay, and it is self-verifying, self-executable, and it can interact with one account and other account. And otherwise, we can say it can also interact with the other smart contracts. Okay, so this can be triggered through the transactions, and these are the advantage of smart contracts. So in Ethereum, definitely you need to write a smart contract. Without writing a smart contract, you cannot develop any decentralized applications in the Ethereum. So this is what the smart contract is very, very important for developing the decentralization. We can say if we use a smart contract, it is the simplest form of a decentralization, which has the highest degree of security. So this is how, because we are writing a smart contract, that smart contract nobody knows. That is how, based on the smart contract, the transaction agreement is enforced and no third party and all involved. This is how the security state is little bit high here in the Ethereum network. Okay, so here we have, these are the advantages as smart contracts. As we say, the speed will be there, highest security will be there, then low transaction cost. As we saw there, uh, if you remember, the ether cost is $100, whereas the Bitcoin cost is $3500. If you could remember, you can map this here. Okay. So this is a simple use case of smart contract. See, digitally now, the real estate has been slowly moved to the blockchain networks. See how this happens when A is trying to sell his house. Okay, yeah. If in this no broker and Magic Bricks, other 99 acres, a kind of thing, this kind of website, if you see, all they are, they're smartly implementing this blockchain into their thing. Okay, if you want to sell your house, what you want to do is like just you need to initiate the transaction. Like I'm selling your house, and it will be distributed and it will be made as a contract. Your requirements, how much price, all those things, what are the rules, what are your expectation, all these things are made as a contract and it will be distributed to a peer-to-peer network. Okay, so it will look for the exact buyer who matches your requirement, and if consensus is given by the miners, then what it will do, the ownership will be distributed, sorry, undisputed, and they will pay value for the whatever value or whatever the gas fee you have been asked, that will be transferred, and the settlement is automated. Finally, the land deeds will be digitized and it will be sent to the corresponding buyer. So this is how the smart contract has been working, and it is a use case. This was the real estate use case that was implementing in the Ethereum blockchain. Okay. So next is the code execution part. It is very, very important. So after writing the smart contract, what we will do, we will make this into a execution part. So we need to make this to happen, right? So how we make this happen? We already discussed what is EVM, Ethereum Virtual Machine. So similar to JVM, I said no. So it compiled a code from a high level language to the bytecode, and which is used to change the state of a blockchain. Okay, that is a smart contract. It is get executed here. So how the transaction stores the entire state and all, we will see here. So this is what about the Ethereum virtual machine, and what is the languages used, higher languages used to create here is Solidity, Serpent, Viper, Newton, Julia. So Solidity is, I already said, Remix IDE. In Remix IDE, Solidity is mostly used to return write the smart contract. The smart contract actually, a smart contract is developed in a Java language or JavaScript is used, whereas Serpent is used, you know, uh, it is an assembly code which is written on Python language. So that Serpent is one of the other languages which is also used to write the smart contract. Similarly, Viper, uh, again it is based on the Go language. Mutant is like it is based on completely C, uh, and Julia is also one of the language to write the smart contract. So the image that shows you there is nothing but the Solidity program smart contract that is given there. So which you might be knowing more detail how to start with the Solidity programming and all. You can have it in another session, that is probably tomorrow, you can know. Uh, Here I will say the major languages used is Solidity and Serpent, and that difference we will see here. Okay, Solidity is Serpent. Okay, if you see Solidity, it is nothing but similar to a JavaScript, which allow you to develop the a smart contract, and it is compiled to the EVM bytecode. Okay, so it is most popular here, a language, and which is most widely used, and it is written probably in high level language. And Serpent, as I said, it is similar to the Python, which can be developed the contract and compile EVM. I mean, sorry, it can be compiled and come to an EVM bytecode. Okay, so it is very simple to write, and the efficiency is more than Solidity because of it is a low-level language, and it is used to ease to program. Okay, and at the same time, adding a special domain-specific features for contract programming. So those things are the added advantage of the Serpent. So based on the again, I can say like based on the use case and applications, we can choose a contract languages. Either you can go with Solidity or Serpent. Okay, so this is what the development workflow I like to show you, like how Ethereum works. We have learned a lot of terminologies. What is client? What is ether? What is gas? Okay, what is gas limit? All those things, terminologies we have learned. What is account? What is wallet? What is transaction? What is cryptography? Now, how to implement this? So we have studied the cryptography. We have studied. I mean, we have seen smart contract. We have seen transaction. But how this happens in the development workflow? So what to start with? Okay, so this is the you can say the sequence how it has to be progress. From create account, then you need to fund that particular account. You need to get fund. Okay, so if in case simply I am creating account in my bank, do I purchase anything in online or in offline? Will it be possible? No, right? So I need money in that particular account. So get money. Chat is there. Okay. So you might be getting loan, or you can transfer from any other friend's account. The similar way here also, you can mm, do all those things. The same way, you need to create an account, fund the account, then you need to develop the contracts, you need to compile that, then you have to deploy, then test. So these are the 6-step process, or you can say 6 stages in a Ethereum application development. Okay, so create account. So there are several tools to create account. So these are the things: MetaMask, TestRPC, myetherwallet.com. Okay, or by program also you can create. Okay, then how to fund this? You can receive ether from your friends, or there is a site called FAUC. I will show you what is Faucet. You can get money from Faucet. Okay, then you need to develop. So develop is nothing but you to write smart contract. So smart contract can be written in Solidity or Serpent based on application, as I said earlier. Then compile that. Okay, so EVM will do your job. Okay, it will comply and deploy with the connector. For deploy, you need a, you can connect with the external libraries that are running, which can communicate with the other peer networks. Okay, then finally it will test is done by interact, and test will be done by the test RPC network. So we have a test RPC Ethereum JS code in github.com that you can refer there. So this we can locally develop, or you can test that particular thing in test blockchain network. Okay, these are the development workflow we have, and the advantages. Uh, the advantages, benefits of Ethereum, you can say it is unchanging nature. Okay, it is more secure, zero downtime, debasement, and seal. Okay, these are the more benefit of Ethereum, I can say. So this is how the benefits are there, and you can develop the application using Ethereum. Uh, So I have this much of demo. If time permits, I can show you probably demo. So whether these things are already seen, like someone can interact me. Have you seen the block? How the block is created? How a hash is calculated? These demos already?
No, sir. No, sir.
No. If time is there, ma'am, can we proceed with a demo?
Yes, sir. We can.
Okay, okay. So I will go with one by one. Like so, if I click this, will it redirect? Okay, it's asking. So this is a basic demo of like how a block is created. It's a site called andresbrowner.com. See here, block is there, the nonce value is there. I am writing any data like welcome to welcome to blockchain. Okay, see automatically my hash value is calculated, and if I give mine, what it happens, you can see. So if when I click mine, so automatically I'm getting added to a existing blockchain. So if I see, if I change something here, AM session, and I am giving mine. So automatically my hash is calculated, the nonce value change, and it is mine. If you see here, yes, see here, you can create so many blocks. You can add the data here, whatever data you need. You might hear that previous hash and the current hash and all, right? So see the same thing. Welcome, I am writing here, and my previous value is 0 because this is the first block. Okay, I can say is I am giving it mind. Okay, see this current hash value will be given here as the previous hash value in the second block. Okay, see here the hash value is 0001. The same for the block 2, the previous hash will be the hash value of block 1. So this and all you might be heard already. So this is a demo of that, and you can also see if a similar way I can add many blocks continuously. Same way the next hash will be there. Whenever I give mine, that data will be mined to the blockchain network. Okay, so this is one of the demo part. And So hash calculator, if you want to calculate the hash value, so you know how a hash algorithm works. This is a site to calculate the hash calculator. So Velour Engineering College, I'm giving the text here. Okay, so I am just clicking calculate hash values. See how many kind of hash values are there. If I, I am altering one word, so check here. We have MD2, MD4, MD5, SHA 1 256. So probably this SHA 256 of block size and all 32 we will be using mostly. You might be in blockchain network. So this SHA 256 algorithm. So we have no this much of hash values here. Whatever the algorithms hash you want, you can use. Okay. So see this value A07824. If I am altering any one letter, okay. Now you see the hash value. See, earlier it was some other thing. Now it is for 47. So this is why the hash value is mostly calculated and used in the blockchain, and we call this as more secure, right? So this way you can easily calculate the hash values for whatever the text you want, whatever data you can encode here. And the next one, I need to show you the MetaMask IO. So MetaMask IO, I said like browser-based wallet. So which I can add as an extension here. Okay, so already I have an extension. So this is how the MetaMask will be there. It is asking for a password. Yes, it has went down. So see here this is a Ethereum mainnet. I said no, various test network. You have also have local host. You have Covan test, Roposton test network. Okay, this kind of Ethereum network are there, but we are now in Ethereum main network. So this is the account address. Here, see you can see your account details. This is your account details. You can export your private key. Okay, so it is asking for security. So I said no. See, private key is like this, and account address start with 0x. We saw in slide, right? So this is how the account address and private key looks. Okay. Then if you want to, buy or send amount from someone else, so buy means see I have this much. You can directly deposit or Ether, or you can buy from this where they are adopting some, or they are funding agency, or you can request from faucet also. So the faucet I will show you here. So this is what that faucet. So if I have zero balance in faucet, what I can do? Uh, so this it says like please select the correct test network. So I need to change my MetaMask network Ethereum. I'm changing my test network. Okay, see now it is coming here. So request one ether from faucet. If I am giving this, I will be receiving ethers to the. For this, I am receiving the transaction code also. So this is what the demos are. And I said like ether scan IO. This is another thing I need to want to show you. So here you can see the ether price. Okay, what are the transaction? How many transaction are done? And what are the recent transactions? See, 32 seconds ago, a transaction has been done. 2 minus 238 runs. All these blocks, how many blocks, how many transaction, all the detail you can view here. So this is what the Ethereum main network gives. That Ethereum scan.io. You can see all the transaction and all the blocks, what are the latest blocks has been recently appended, and what are the ether price, how many transaction has done, what address to which address, see how many ether has been, amount has been. This is a public, blockchain network, I can say. Yes. Hope you might be enjoyed this session, and that's what. And we have our own, Tamil from our state. It's a Namchain initiative. Ramaguru Radhakrishnan, he is one of person, who has started this initiative Namchain. He is also working with the TNAGA agency. Okay, so you can also refer him for more uh, kind of blockchain information. The most recent project of them are also listed here. So these are the references, demo links I have, and these are the references I have used for the presentation. And finally, any queries, if you have, you can ask. And thank you for the opportunity given to the meeting. Any queries?
Participants, if you have any queries, please unmute yourself and raise the hand, or you can post it in the chat box. Okay, sir.
I
Thank you,
think
sir.
everybody has understood. Okay.
Thank you, sir. It was really an informative session for all of us.
Thank you very much, ma'am. Thank you once again for all participants to listening patiently for my session. And once again, I thank the management and coordinators of CSE Vellalar Engineering College for giving me the opportunity to present here.
Thank you, sir. Thank you for your valuable session, which will certainly improve our knowledge in blockchain. We are eagerly looking forward for more such interactions in the years to come. Thank you, sir. Participants, kindly join the 10 a.m. tomorrow. Thank you.
Thank you.